Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about finding volume. When we're finding the volume of a shape, we're talking specifically about a 3D shape. So it's not just a square or a triangle, it's an actual prism or a cylinder or something like that. These are our three-dimensional shapes. I know when you look at this, it can be overwhelming. You see so many shapes, and we've actually got a few more we're going to do on the next page too. And you might be thinking, like, there's no way I can memorize all these formulas. It's too much. Because it visually can be overwhelming. But I think you'll find that there's really a pretty basic pattern that we follow with each one, specifically, especially for these first four. And if you can memorize these first four based on the pattern, then the next couple ones we do, starting with cone, will be a breeze because they build off of the ones you've already memorized. So I'm going to start just by talking in general about volume. So when we find the volume, especially of these four first ones we're going to talk about, we look at the area of the base, whatever the base of the shape is, and then we just multiply it by how tall is the shape, okay? So for this first one, for a rectangular prism, when we find volume, we're just asking, okay, what is the shape of the base? Like the bottom part of this picture, hopefully you can see that that's a rectangle, right? This is a rectangle shape. So we just find the area of the rectangle and then multiply it by how tall the object is, the height, right? So when we find volume, hopefully you know that the area of the rectangle is length times width. If you don't have that memorized, that's going to be definitely one that you want to memorize to keep in your math toolbox, if you will. Length times width. That's how we find the area of a rectangle. So we take that area of the rectangle, which I've shown here in parentheses, length times width, and we just multiply it by how high is the object, how tall it is, right? So we've got this flat base, and then just how high does it go. Cube, it's very similar to a rectangular prism, except that it's actually, our base is a square, okay? And if our base is a square, that means the width, the length, and the height are all the same distance, right? They're all the same length. So when we're finding the volume, we're actually going to find the area of the base, which is area of a square, and then again, we just multiply it by how tall does it go. So find the area of our length times our width, and then just multiply it by how high does it go. And you'll notice it's the exact same formula here as it is here. Volume equals length times width, that's the base, and then just multiply it by how high it goes. Now, for a cube specifically, a lot of teachers like to teach, well, you should recognize that the length, width, and height are all the same distance, right? So if this one is 5, then that one's also 5, and that one's also 5. So we don't need to show each of these values, right? You can just show it by saying the base, just one of the side lengths, cubed. Okay, so I see a lot of teachers use this one as well as this one, so I just want to point out to you that these are the exact same. I kind of like using this one because these are the same, right? So if you memorized one, you memorized both. Okay, let's look at triangular prism. We covered rectangular prism, now we're going to look at triangular prism. And this one can be a little confusing for students. When you look, a lot of students will see this shape right here, and they will say, oh, okay, well, the base is a rectangle, because that's what it's sitting on. So the bottom must be a rectangle, so it's just the area of a rectangle times how tall it is, right? Wrong, because if that was true, then it would look like this. Isn't that what we found there? So we have to be very careful. The base of a triangular prism is actually the triangle part. So really, this, if we were sitting it on its actual base, would look like this. And you'll see both. It's important to recognize these are the same shape. They've just turned it on what looks kind of like its side here. They've just put it as the triangle for the base. So just be careful, okay? If there's a triangle face, that is the bottom, okay? That's our base. So when we find the volume of a triangular prism, we're finding the area of a triangle, that's our base, times just how tall it is. So I like this picture. I feel like we see this one more in math. Or at least just I personally have, but I like this picture because we're saying, okay, what's the area of the bottom? And then just how tall is it? And it can be tricky because remember, the area of a triangle is 1/2 times base times height. And then we're multiplying by that by the height. So a lot of students get confused. They're like, well, which height is which height, right? So we have our height of the actual face of the triangle. That's our 1/2 base times height to find that area. And then we have our height, which I showed with a capital H, of how tall is it, right? How tall is it? So just try not to get those confused. And here's the great thing. A lot of students are like, oh no, I don't know which H to put where. Here's the thing. It doesn't actually matter, right? Whether you put it here or you put it here, you would get the same answer because multiplication is commutative, and which means we can flip things, order doesn't matter. Okay, so just be aware of that. And again, you don't have to have these parentheses here. I'm just showing you that's our area of the triangle times how tall it is. Okay, let's look at a cylinder. So a cylinder, notice that it has that circle base, okay? And then again, we're just saying now how tall is it? So to find volume, we just find the area of the circle and multiply it by how tall the actual cylinder is. So area of a circle is pi r squared. And R stands for radius. So the radius is if on this base, this face of a circle, right? If we had our center here and then found the distance to the edge of the circle, that's called the radius, that distance right there. Pi times the radius squared, and then we just multiply it by how tall is the item. Now, our cone is where things switch up just a little bit. And there's different ways you could explain this, but I'm going to explain it in the way that I think is easiest to memorize. So when we're finding the volume of a cone, it's important to note that this cone comes up to a point, right? There's a point at the top of it. So any of our 3D shapes that come up to a point at the tip top, there's a special rule for those, and it's going to be that we take 1/3 the volume of the completed shape. Now let me explain what I mean by completed shape. Like if I were to just add another cone right here, right, and another cone right here, what would be the resulting shape? And the resulting shape would be a cylinder. Right? Like if I were to extend this cone this way and extend it that way, I would end up with a cylinder shape. And there's some great video tutorials, other video tutorials where they actually show this, like with water pouring into cups. It's kind of cool. You might want to check those out. But it's really interesting to note that a cone is just 1/3 of a cylinder. So when we find the volume, that goes into our actual formula. So it's just 1/3 times the volume of the cylinder. So if you have your volume of a cylinder memorized, all you have to do is throw a 1/3 out front and you're good. Okay, so that's why I say, like, if you memorize this one, then this one is super easy. We just do our 1/3 times pi r squared times height. Another way to write that, a lot of people like to go ahead and distribute the 1/3 in. So an equivalent way to write this would be volume equals pi r squared times h divided by 3. So again, our h is our height. Both of these are completely acceptable. I like this one just because just personal preference, but you will definitely see this one as well. They're the same thing. Either one will get you the same answer. Let's look at a couple more 3D shapes. The next one we're going to look at is a square pyramid. So notice, make some observations about this. First off, the base is, whether you look at the name or whether you look at the actual picture, your base is a square. Okay, so that's good information. But you also want to notice that it comes up to a point, just like that cone we looked at on the last page. So anytime we have a 3D object that comes up to a point at the top, that's when our 1/3 rule is going to apply. Okay, so let's think about what would this shape be if we completed it, okay? Meaning if I were to complete it on this side and complete it on that side. And again, it can be kind of hard to see until you like really visualize it. But if I were to complete the square pyramid on both sides, I'd end up with a cube. So if I know that a square pyramid is just 1/3 of a cube, then I can apply that to my volume formula. So a volume of a square pyramid is just 1/3 times the volume of a cube. So let's think back to the other page of what our volume of a cube was. Well, that was length times width times height, right? So if you just throw a 1/3 out front and multiply it, then you're good. You've got your volume of a square pyramid. Now, it's important to note, and it kind of goes back to that some teachers really don't like using length times width times height with a cube. They're like, no, you should know that all the sides are the same, so we just call it b squared times height over 3, okay? So basically, they're just recognizing that these bases are the same length. Okay, so just keep that in mind. You will also probably see this, and this are the exact same. Okay, it doesn't matter which one you use. Again, I like this. I feel like it's easier to remember, but if you see this, it's going to be the same. The next shape we're going to look at is a triangular pyramid, and this is going to be the last ones of our pointed top that we're going to look at on this video. Again, anytime you have that pointed top, that's when that 1/3 rule is going to come into play. So we've got to think, what would be this shape if I had another triangular pyramid here and another triangular pyramid here? And it can be kind of hard to visualize, but I'll go ahead and let you know, if you had 2 more triangular pyramids on either side, it would be a triangular prism. Okay, and we talked about triangular prisms on the first page. So if we just take if we're looking for the volume, if we just take 1/3 and multiply it by the volume of a triangular prism, then you'll be good. So remember, our volume of a triangular prism is 1/2 times base times height of how tall the item actually is. So remember, this one is the one that kind of goes into that area of the triangle, so the actual face of the triangle. This one is how high does the object actually go. 2 different H's there. So some teachers like to go ahead and distribute that 1/3 in, and so they get this equation. So volume equals 1/6 times base times height of the object. Either one of these, again, are totally fine. Again, I like this one because it's easy for me to remember. Okay, it's just 1/3 volume of a triangular prism, but you got to find what works for you. Okay, our second to last shape we're going to look at is a sphere. A sphere is like a 3D circle shape, kind of like a globe. I don't have a fancy way to memorize this one like I do the other ones. I'm sure there are some great ways out there. I just am not familiar with any. For this one, we're just going to want to straight up memorize. So the volume of a sphere is 4/3 times pi times r cubed. And again, that r stands for radius, which is the center of the sphere to one of the edges, so that distance there. So 4/3 pi r cubed. So that's one you're just going to want to memorize. Hemisphere is actually pretty easy once you know sphere. So a hemisphere is just half of a sphere, right? So it makes sense that our volume would be 1/2 times the volume of a sphere, because it's literally a globe just cut in half. If you can remember that, and it's pretty easy visually to see that, our formula would be 1/2 times the volume of the sphere, 4/3 pi r cubed. Another way to see this written is to go ahead and distribute the 1/2 in and get volume equals 2/3 pi r cubed. Either one is totally correct. Again, I kind of prefer this way, but whatever works for you. Let's look at some examples of finding volume in action. So in this first example, notice I've got a cylinder shape, and if you remember, which hopefully you're maybe starting to memorize, volume of a cylinder is the area of the base. So the area of a circle is pi r squared, okay, times the height. So in this case, our volume, or our V, right? Volume is pi, and then what's our radius? So luckily it told us, remember, radius is the distance from one side of the circle to the center. So in this case they told us it was 3, so 3 squared. And then that's times the height, and the height in this case is 5. So we'll put times 5. And this is awesome because we can just put it in the calculator at this point. So we cut our calculator on and we just type it in. So to get that pi button, you hit second, and then the same as the little exponent button, right above it, you'll see a blue little pi symbol. So we get pi, and then we want to multiply that by 3 squared, and then multiply that by the height, 5. So we get 141, and then we've got a decimal, so let's just round to the nearest, I don't know, hundredth. Let's just say 141.37. So our volume, 141.37. Now, it's always important that we label, 141.37 what, right? So in this case, we're working in inches. So we would want to say inches, and then this is so important. Because it's a 3D shape, we call it inches cubed. So when we're finding like area of a 2D shape, like just a basic square or basic circle, then we would call that inches squared, right? But because we're working with a 3D shape, we call it inches cubed. So that's an important distinction to make, and you always want to make sure you include your units. Okay, so let's move on. This one, notice, is a triangular prism shape, like we did on that first page, and I've purposely placed it laying flat instead of on its actual base, because these can be very tricky situations when you see them, to really identify it and identify what is the base. So remember, our base is our triangle, our volume, remember that it is the area of the triangle, so 1/2 times the base times the height, and then we multiply that by how tall the item actually is, right? So we have the area of the face, but then how much does it extend, right? So in this case, it kind of looks like length more than it does height, and that's fine. Whether you want to think of it as length or height is up to you. We want to fill in our values, so our volume, if I can spell, volume, is 1/2 times, now our base would be our 9 centimeters, times our height of the actual just triangle face. So in this case, it's 7. And then we want to multiply that by how high the actual object is, which is 20. Okay, so at this point, we'd want to bring our calculator out. So we have our 1/2 times 9 times 7 times 20. And that gives us 630. So we would say our volume is 630, and then we always want to look at the units. So we're talking about centimeters, right? Centimeters, and this is a 3D shape. We're finding volume, so we say centimeters cubed. Okay, in this next example, notice we have a pointed top. At the tip top, there's a point. So this would definitely be our 1/3 rule. In this case, this is a triangular pyramid. So remember, our triangular pyramid is our volume equals 1/3 times our triangular prism volume. Okay, so it's 1/3 times 1/2 base times height times big height, right? So let's go ahead and just fill in those values. So our volume is 1/3 times 1/2 times base. So remember, this is the base like of the face of the bottom of the pyramid. So in this case, our base is 17. So 1/2 times 17 times the height of the face. So in this case, it's this height down here, which would be 12, times the big height, how tall is the actual pyramid, 14 feet. So again, some people would prefer to write this as 1/6 times these things. It's totally up to you. So in order to find our volume, let's bring out our calculator. So we got 1/3 times 1/2 times 17 times 12 times 14. 476. So we get 476. And this time we're measuring in feet, so we'd call it feet cubed. And then for our last example here, we have a sphere, like a globe shape. So remember our volume formula for that. I don't have any fancy way to memorize it other than just straight up memorizing it. So 4/3 times pi times the radius cubed. Okay, so we just want to fill in the information, which in this case is just the radius. So volume equals 4/3 times pi times 3 cubed. So we'll bring out our calculator and actually type that in. 4/3 times pi times 3 cubed. And we do get a decimal here, so let's just round to the nearest 10th. Let's just keep it easy. So volume equals 113.1. This time we're measuring in meters, so just meters cubed. Okay, so here's a U-try for you guys. I will post the answer in the video description below. This has been Miss Math Tutorials.